Hello and welcome everyone to this webinar today. We will be talking about precast detailing in impact. This will be a part one in a three-part series of webinars. Today we will focus on beams, columns and hollow cores. And as a matter of introduction, since this is my first webinar, it's TrueSoft. I am Michał Sikora. You may know me from some tips of the week for the last couple of months that have been uploaded. I'm a business development manager at TrueSoft. And I'm based off in Krakow in Poland. All right, so without further ado, let's move further. So today we will focus, as mentioned before, on beams, columns and hollow cores. We will be modeling beams and columns and hollow cores as mentioned. We will also design a corbel with impact and apply that to our column element, as well as we will be deciding on the reinforcement in that corbel. We will be inserting some casting materials either in the corbels or in some other elements in the presentation today. I'll also demonstrate to you rebar templates and functionality of those for the particular structural elements that we'll be discussing. We will save the elements to Impact database. After saving those elements to the database, we will be able to preview those in Impact Project Manager. And of course, we will be generating shop drawings as can be seen in the preview on the screen here. Okay, so let's move out to AutoCAD actually. I have a model prepped with a grid for us to follow in this particular session. So we can immediately start. If we have a grid, then we can start drafting elements. Well, we could without even a grid, but grid helps. So let's start with columns. I'm going to select the column tool and I will be able to now select the dimensions of a particular element, right? So I will choose a 50 by 50 column. Let me just find it. And immediately in the preview, you will be able to see some reinforcement applied to this particular column. We can accept that. That's one of the templates that's already predefined in the standard that I have here. We can add to that standard. So for this shape, 50 by 50 centimeters of a column, we can add different types of reinforcement or other different templates of reinforcement, but we'll focus on that a little bit later. So I'll first accept what we have here. So just this one. And I'll show you later how to modify that, or rather how to add to the standard, to the definition of the columns that we have, so we can use that further down the line in the design. Next here, after choosing the type of column that we want, which is 50 by 50, we actually need to specify how tall we need that column to be. By default, typically column is selected to be 1 story height. So if our floor is 3 meters tall, then that's basically, as is the case in this particular example, 3000 millimeters is the default column height. But I want this particular column to go to the top of the second floor as well, so I will increase that to 6000. Yes, that's nice and even value, but I want that to be easy for us in this presentation, so 6 meters it is. Next is a matter of selecting of casted materials lifts for our element. So that's the either by section or by user, so we can define that either by ourselves what type of lift that is. In this case it's by section, so this particular section has defined some type of lift here. It's not selectable if I go by user. This is selectable to a different type of lift, but I'm just going to leave it by section. All right, and side, so basically how the column is rotated. And the other tabs that we have available before placement is top. So basically the shape of the top of the column. If you want to have an angle and slope to the top of the column for maybe architectural reasons or structural reasons, we can do that. Or we can automatically apply a corbel to that as well. But let's leave it simple for now. Next section, something that might have come up in tips of the week, but we can locally change the section of the column. So make it either thicker or thinner, or different shape entirely in a particular, for example, for a particular height, maybe on the bottom of the column. And model specifies the assignment of that column. If it's assigned to the first building, for example, first floor, or the phase, what's the presentation of that column, if it's solid or wireframe, if we need to lock the elevation. This is a function that I'll be using later for other elements, but we'll see that. And the placement of the column, or the insertion of that column, and in this case it will be by the center, as it will be very easy to just click on the intersections of the grid. So let me do that for us. Let's place the columns. And for this particular scenario, I'll be placing my grids, my columns on grids in this line here up to 6 and C's. But so let's do that. I'm just going to be accepting the rotation of the columns, placing them one by one. Very simple and very quick as well. Not much to it, and that's done. I'll just press space to accept the selection. We can of course rotate the model now to 3D, see how it looks like. So we have our 6 meter tall columns, and I can just, you know, go back to the top view for us. But I'm not done yet with it. What I want to do is I actually want to add another column in this area. So on the axis B, I want to add shorter columns of a different shape. So let's go 50 by 40, so more square-ish, other rectangular-ish column. And for this one, I actually want to be just 1 story high. So let me do that. And the rotation, I want it going this way, right? And same thing here. Leave it like that. I could of course change the rotation in the insertion point, but you know, we can leave it like this for now. And again, we can rotate the model so you can see they are in fact shorter. So as you may have noticed, like we are working on a basically floor plan basis from our model, and we create 3D objects in that floor plan. All right. So with this, we are now done. I'm just going to have a look at my cheat sheet on the right, just to get like know the order of operations that I've planned for today. So with that said, we're done with the column placement. I'm happy with that. We still have plenty of room to expand upon that structure on further webinars, but columns are for now done, right? What we can do now is we can play around with the reinforcement of those columns. So let's go back and open up one of the columns and go back to the properties, just to remind ourselves. There's a reinforcement, there's a template. This template gives us some insight into how the reinforcement will look like. We won't be able to see 3-dimensionally how that reinforcement will look like, as this is something that we in the Impact for AutoCAD we do at the drawing level. So we can apply a template, but then like the reinforcement we will see only on the drawing. So not a problem there. But in order to modify the rebar template for the columns, we actually have to go to the definition of the columns. I have to one definition in the project itself. Let me import the definition of the columns as well, the 50 by 50. Oops, I didn't import that. You always need to import and accept that. So we have our column here, and let me edit that. And in the edit, I can go to the reinforcement tab, and we see those 2 templates that I had for selection before. I can click on those and see if there are any changes. There are some. Some only have additional reinforcement at the bottom of the column. Some don't have additional. This one, for example, has like additional strengthening reinforcement for shear for the second bottom. section. But how can we add a reinforcement template to a section? It's easy. We just right click in the template section, create a new, and for example, whatever we can type in whatever we want, whatever makes it easy for us to understand what that is. So say let's change the way that the description is here for something like diameter 6 at 300. So say and maybe main rebar, like let's go maybe 6 times 20, 6 times 20 plus 6 diameters at 300. Or maybe let's go, yeah, let's go to 6, maybe 8, maybe 8. So more rebar, so you can see a bit more reinforcement in the section. Well, let's accept that. And another window immediately pops up for me to specify like either the number of straight bars or the stirrups. So the first one is stirrups. So I can utilize all the tools that I have here. First, the shape code. So is that like an L bar? Or other L-shaped bar or a different type of bar. Let's go maybe with a 51. Bar mark none. We can have a new bar mark 51. And now we can specify that new type of bar mark like so. And quality, we can make that quality of steel B for now. Jig radius, so basically we specify the dimension, so the basically the diameter of the bar for stirrups. Let's leave it at 6 because I defined that at 6. Jig radius, that's basically a bend radius for the bar. Some remarks for that, those are not very important. The way this shape code works, we have basically the A and B dimensions, so best to just show it. Let's go 400, all right? And so this is our A dimension, and B dimension will be, for example, the height, 400. And our C and D dimensions are basically the bent legs that we have in this shape code. So let's make those more reasonable, 100 and 100. Now with the scale slightly better visible, you can clearly see the like bends in the corners of that. And that's enough for this. So that's the shape code that we have, 400 by 400. The column is 500 by 500, gives us 50 mil cover each side. So let's accept that and let's use that. And immediately you can see the bar has been placed on that preview. So it's just a matter of actually placing it in position. So let's see 0, 0. Let's go for 50. That seems to be perfectly in the middle. This one seems kind of off, so maybe 350. Yes, this works out for the placement. Maybe I chose it wrong, and yeah, that's the insertion point on this leg. So that's how we can place the bar mark. Now, location from top and location from bottom. Basically, as you can see, that's how far from the top and bottom actually the B-bar spacing starts. So let's go to 50 and to 50, or maybe 300 and 300 here, and 300 spacing for our bars as well. And location top to bottom, we can also specify an area of denser reinforcement. So this is number of bundles in second, distance first to second. Basically, here we can specify if we need some additional shear reinforcement for top and bottom of the column. So we can do that. Like we can go 150 here, 150 here, 150 here. So it will work out nicely with the spacing. And that's both for top and bottom when I'm setting that up. And let's maybe make 5 and 5. Yeah, 5 and 5 bars. We'll see how that looks on the drawings. If it needs corrections, then we can of course correct that later. Now, let's go to straight bars. And for straight bars, we need to assign a cover. As mentioned, I have 50 mil cover for the stirrup. So let's make that 60. Yep, that works out for those bars. And let's go bar size 20. Okay. Now, corner bars is just 1 bars in corners, but then we can specify front and back number of bars in front and back, so that can be 2. And we can also specify number of bars left and right. So let's make that 2 as well. Okay, so that's a bit overboard. Let's go maybe 1 and maybe 1 here, 1 here as well. Okay, so that gives us 8 bars in total for this, and we can accept that. And of course, you can see that in the preview. Okay. All right. And we can specify which template is the default for our bars. We can, of course, not of course, but we can also specify the exact positions of the bars if needed. So you can see the bars are highlighted. We can change the position if that would be needed for a particular case. Right. So that's how we can do that. So let's accept that, and let's accept that that template. What I'll do now is I'm going to select the columns in question, so those 50 by 50. I can either go back to plan and click on edit columns, or I can just double click after selecting those and get back to that. And you can immediately see that we have our preview. It will take a little bit to load on that preview of the template of reinforcement that we have. Just maybe switch back and forth. Yeah, and that loaded. And that's it. I can save that, accept that, update lifts. And now this reinforcement template has been applied to our columns. So now we are kind of, but not yet done with the columns. We'll still be adding corbels, but corbels, it's easier to have the beams first. So let's do that. Let's go to the beam tool. Let's draw a beam, and we'll just use a typical rectangular beam, and that's going to be size 18 by 58. So a big beam like this, and we're going to use the standard reinforcement template that we have for this particular beam. We can also specify lifts here as well if we need to change something at the ends of the beams, which we will, but that will do after we're done with the corbels. We can again modify the section at a specified distance, for example. So if we need to make a beam bigger or smaller an area, we can do that, as was with the case with the columns. And the last one is the placement. Now this one I will use because I want the tops of my beams to be at the elevation of the top of the column. So I can do that very quickly by changing the placement to top center instead of bottom center. So as you can see in the preview, this is my alignment point, or rather my insertion point. I want to lock the elevation. So because we are working in 3D model, it's easier to lock the elevation to a specific point if we're placing horizontal elements, so we know we are keeping that elevation. Sometimes we can snap with the AutoCAD to some point that we don't really mean to do that, and then it will be at an angle or placed very weirdly or not exactly how we want to do that. So worthwhile to do that. Let's go to 6000, and that should be it for the placement of those columns. I don't really want to modify anything else in this particular scenario. So I want to do that. I want to specify the first point here. I also want to apply offsets. So they're not exactly flush with the columns, because that's offset left and now offset right. And as you can see, we are now offset with the beams. Because leaving those elements flush, not exactly perfect. Simply put, it might be hard to place those elements on site if they're flush. Or we might crack some concrete or do something we don't really want to do. That's done, and just last one on this side of the building. Place it Did I place that correctly? I think I did not. So I'll just go back to that and replace that later. I think I snapped incorrectly on that one. Not a problem. Non-stressed beam again. Same thing. Yes. Yes. Yes, and yes. And the last one here. It's good. What I'm going to do is I'm going to do such a little thing because I'm pretty sure I missed that element. Of course, if I want to snap those elements now. Oh, my column is off. I'll need to correct that as well. Okay. Yeah, that's a mistake. Let's delete this and let me delete this column as well. Now let's place that column. Yeah, now let's go the 50-50. Let's go 6,000. Yep. And apologies for that. I want everything to be aligned nicely. Yep. That's my column. For some reason it's rotated. That's probably because I used a different column. Okay. It might be easier to just do this. And yep. Easiest solutions are the easiest. Yep. And again, just verify that we have locked. Yeah, we've locked the elevation. And now yep, that's done. Let me verify if the column didn't run off. Everything looks good. Yep, so we have our beam. It's exactly as I wanted it. Let's go to the front view. So my top is flush like that, but we are not done. Oopsie, let's turn that off. Let's turn off the properties, don't need those. Let's go to the top view. Okay, now what I want to do is I also want to place some beams here. Those will be my supports for hollow cores later. So let us do that, right? This time I'm going to go not this one, but ledge the beam. Yes, that's this one. And let's place this one. Nope, those are the ones that I want to use. Okay, different thing now. Let me verify the placement. The top I want to have at not 6,000 but 3,000. Top center, that should be good. Ends, fine. That should be good, and we are okay to go. Now, one thing that's important is the direction in which we draw the element. So I want to go from bottom to top, so my my ledge will be on the right side, which you will see right now. And offset is applied. I can see that, which is good. Yep, that's good. Same thing here. Let's apply that. Yep, that's clicked. Now I will go the other way around, so from top to bottom for the left side. Yep, and like so. Okay, so if we rotate the model, now we have ledge beams, as you can see, solid geometry here, and yeah, that's how we can place those elements. Basically, we're pretty much done almost with our columns and beams. One more thing that we need to do. We actually need to create corbels. So this will be easy. Let me go to top view again. This will be very easy. there's a couple of ways we can do corbels. We can either draw a corbel by selecting a column and deciding if you want like a single corbel, double-sided corbel, and do all the settings manually for everything. Or we can utilize the draw corbel from element, which will make impact look if there are any beams next to your columns. Right, I'm just going to do that, select all the elements, and it will apply the corbel geometry automatically wherever they are needed for our columns. Okay, so there's a bunch of settings we can do. There's a template predefined, for example, in my standard, which gives me some basic dimensions, but I can of course modify those if I want support to be bigger than 250 mil, the height of that, the H2, so height of that basically corbel. If I want that to be 250, then yeah, it can be. The overall height, half a meter, I can change that now. I'll leave it as is. It's good enough for a demonstration. One important thing, you can specify if you want to have a fixed width of a corbel, or if you want to have, or you have, for example, a width of the corbel to be the width of the element. So in this case, a column, right? I'll leave it as by element. I personally preferred it that way. Of course, if you need thinner corbels for maybe like thinner elements, or maybe you want the corbel to be offset by to one side, of course you can do that. Important thing, you can also specify cast-in materials. So for your lifters, for your corbels, you can specify that in the cast-in material section. All right, so let me just accept that. I want to now specify a gap between the corbel and the element. So there is some, for example, like a rubber bearing or whatever for the columns, or just some leeway tolerance available between the corbel and the beam. I'll just leave it at 10 mil, and it's done. As you can see, the corbels have been added to the columns, like so, and it doesn't even matter for the software that those beams are at two different levels and going at different directions. It basically recognizes, okay, this column has beams here and here, we need to support those, and there's beam as well here on the lower level, let's support the beam as well. So here it is, that's for us, that's done. The reinforcement of the corbel, we'll be doing that later at the drawing stage actually. Okay, so let's go back to top view, rotate that. With that done, we can go ahead and actually start placing hollow core slabs. But before we do that, because I will be supporting my hollow core slabs on those ledges, I do not want to, I don't want to my hollow core slabs to go through this. I can just click through like points wherever I want to have the area with our hollow cores, but it might be easier to do it by first creating an area that will create a cutout in our hollow cores. So let's go and utilize the draw recess filling. I just want to do that in a slab. I want that to be cut out, so it will go through the whole slab. It won't be like a recess in the slab. It will be a rectangular opening. It could be circular if we need to create a hole in a hollow core slab, because we can use this tool to also create holes in slabs and in elements in general. Yeah, and that's sufficient. What I'll do now, I'll specify that on screen. So this will be my my origin point for the rectangle, and I want to offset that. I want to create an offset of 50 millimeters of that face. So that's one, and let's create the one on the other side as well. Okay. like this. And now my recess is prepared. It's prepared, so I can now draw the elements. The depth of the support, as far as I remember, again, that's 150 mil for the ledge. So let's say we'll support that by 120 mil on both sides. Let's go with hollow cores now. So that's our hollow core definition tool, or the hollow core drawing tool. We have predefined shapes of hollow cores, so that depends on what's in the standard that's prepared. So basically sections that you can select. We also can prepare strand patterns. So for example, like 5 strands in the bottom, 2 strands in the top, or maybe 6 in the bottom only for your pre-stressed strands. Let's maybe go with 5 and 2. There's also like the specification of like if you want to apply pre-stress to those, you can make sure it's in here. You can define if you want to automatically place in lifts. So that would be by user, and you would specify a lift type, but I'm going to go by definition now. So automatically my lifts will not be placed because maybe you have this special like crane with a hook that will attach to the sides of that. So that's good, but I'll show you in a second how to add those lifts if we need them for whatever reason, or I mean if we need them by design for in our factory, then I'll show you how to add them at a later stage, or you can add them now. End caps, in the end cap section we can go ahead and specify the end caps. By default it's the R1 defined in our standard, or L, which basically is a straight edge. That's it. But for example, let's go with with something that we have HD19U2 as an end cap, which is this nice little rounded cutout. Sorry, let's go and select that too. If you want to add more detail, like a recess or a cutout in the hollow core, then you can of course go by this preview image and add something here of your own choosing. And let us do that now. Oops, let's go back actually, and then actually specify the height at which I want that that hollow core. Okay. My math, will it be right? The height of that is 185. Okay, we might need to lower those hollow cores to sit flush on the beams. We'll do that after the fact, because we can still move the elements in the space after we're done. So let me just select that again and select the strands, and let's accept that. So I can either select a polyline. I don't have a polyline pre-drawn for this, so I'll just select points. And my points for support will be this one, this one, this one, this one, and I'll close that with a C and space on my keyboard. And now I need to specify the support length. I don't want any support on this ledge. I want this to be free edge, so that's going to be 0, and I'll accept that. Now this edge is highlighted green. Let's go and add that 120 mil support. As you can see, the line extended. Next edge, that's going to be 0 again, and 120 again on that last edge. I'll also rotate the hollow cores, and you can immediately see in the preview there will be some cut hollow cores to fit in as many non-cut hollow cores as possible. So I'll just accept that rotation, and I can specify if I want this cut element to be at this location, or just move it around to different locations, right? So you can specify that wherever you want that to be. And you can do the same for the second one. This one is now highlighted, and I can move it as well. And let's just apply that. But you can see that the magenta rectangle here, basically it changed shape, but the hollow core elements actually recognize that cutout, it recognized that it needs some, it basically followed the shape of the cutout, and now we have a hollow core element that's cut out around that column that we have. I'm just going to now delete those because I don't need those magenta rectangles anymore. And with that, our model is almost done. Let's verify the front view of the elevation. Yep, so let's just measure the distance for that and lower those hollow cores to fit. That's delta Z is 255, so let's move all the hollow cores by 0, 0 and negative 245. Oops, okay, let's go. Okay, let's do that from the top view, it'll be easier. That's a bit of a skill issue for me here. Okay, displacement 0, 0, negative 245. Yep, and now let's verify. Yep, that's perfect. So that's perfect. That's the way I wanted that to work for this ledge columns. And now what we'll be left with is, now I just want to place a couple of pre-stressed columns, as we also have those. Those I want to be tapered columns, and those will be this type. Of course, for this particular element, I don't have reinforcement predefined. I could define that again, going to the definition of the beams and preparing proper shapes to have that reinforcement in this. For now, I'm just going to use it as just a pre-stressed beam. My model, I want to use the elevation to be at the top of our columns. Lock the elevation. This time, I want my placement to be bottom center, not as it was the case with the beams on top of the columns, the transverse ones, or the longitudinal ones. Now those roof girders I'll use on the bottom center. So let's do that. I'm going to do it this way. As you can see, or they're not yet, but you will be able to see in a moment. Let me place those on each frame. Yep. Like that. The offsets are still applied from what I gather from the previous placement. If you would want those offsets, you would modify that with the O command now. Okay, so, and space to accept that. Let me go to this isometric view for you. And as you can see, we have now sloped columns, sloped beams, sloped pre-stressed beams. Basically, the software automatically recognizes that it's a sloped section, and it symmetrically tries to place create the slope symmetrically along the center of the element. And of course, the element can be as long as you need it to be. Of course, there's limits in software in the standard that, for example, some element can't weigh more than X amount of tons, or can it be longer than X amount of meters. So that's, of course, and logistically, some elements can be infinitely long as well. So we do have some safety precautions in the software to tell you if the element's too big. Basically, highlight everything red. That means no good. And yeah, that's it. So this would be about it, about the modeling of all this. Now what we need to do before we proceed with creating the drawings, we need to save those elements to the database. So we will be able to see those elements in the project manager, and so we will be able to create, so basically the elements will have their own numbers, and we actually have some elements with names not unmarked elements, so they can have drawings applied. All right, so first things first, let's save the columns to the database. So we have a tool under the columns section, that's the save column tool. I will select basically the whole model. It doesn't matter that I select like beams and slabs with this, it really doesn't matter. Now, let me press enter to select the first column mark being C1, and now columns are saved. You can see you have C1, C1, C7, C3. Basically, our columns are now saved. Let's go to beams now. I'm going to select all of them again, and now I'm asked, because there's a distinction between the non-stressed and pre-stressed beams. Let's go with non-stressed first and make those B1s as first number. So we've got B1s as the alleged beams and B2s for all the beams going along our frames. Now we need to repeat the process for the beams, because we need to also number or rather save to database the pre-stressed beams that we have for our roof. And they're saved, so pretty quick. And lastly, the hollow core slabs. This time I don't have to select anything. I can just click all from the menu. It will scan the model for slabs, and HC1, that's perfect number for our HC1 slabs. And we have a couple of hollow core slabs. So we have hollow cores 1, 2, and 3 basically. With that done, the whole model is now saved. With everything being saved, I can go ahead to Project Manager, and that's this one for my project now. And I just need to refresh or rather update the model. So the database updates with all the elements that we've created, and like so, it loads up the elements. So those are all beams, columns, and hollow core slabs that we've created. You can see we have the alleged elements, we have the columns with corbels, we have the alleged beams as well, and we also have hollow core slabs. And as you can see, we can even see the fine detail on the edge that we've created. If we go over there, we also see the cutout around the column that we have. All right. So with this now being done, we can start creating the drawings basically. So let's go back to our AutoCAD like so, and let me go ahead and start creating drawings from columns through all the elements that we have. It's going to be very simple, couple of clicks, and it's going to be done. So I want to generate drawings for columns. So under the columns section in the ribbon, we can go ahead and generate the drawings. So I need to select all the columns like so. And now all the columns that we have are that I've selected and want drawings to be created for are shown here. I can, for example, change the template for the drawing. This is RP layout. I could change if I want. I can have multiple drawing templates for the columns. Let me cancel it out and just leave the one that I have selected. And it's just a matter of clicking OK and waiting for the program to do its job. So create those drawings automatically for us without much hassle. It's going to take a minute or two for this many drawings to come up. So we just have to bear with the program a bit. Of course, the more elements you select at the same time, the longer it might take, but still, this is 7 different beam types and the drawings are already done. Let's do the same for beams now. Let's go for the non-stressed ones. And as you can see, we only actually, even though we have multiple beams in the model, we only need 2 drawings for the non-stressed ones, because we only have 2 types of those elements. So let's do that. And that will be quicker, as you can see, than the columns, because there's just, 2 drawings. Still things a bit, but that's fine. And it's done. So same for the stress beams now. Let's do that. And let's accept that. Oh, no drawing template specified. That's because I don't have a template for pre-stressed beams, but we can maybe select one. And let's do that. Done. The drawing is done. Now I would like to create drawings for the hollow cores, but first let's show you how to add those lifts that I didn't show you before. So I can go ahead and select objects. So for example, let's add lifts, those elements, and just those three hollow cores, just to demonstrate that we can do that. And yeah, I can specify the type for this particular hollow core. For lift type, I only have this one specified. It shows you a little preview that lifts will actually go into the cores as well. You can specify if you want to have the core fillings visible on the drawings, and how long is the core filling for the lifts, and if you want it to be dimensioned on the drawing as well. All right, so let's do that. Let me accept that, and you can see that those hollow cores are changed now. They're yellow. That's because we've added lifts to them. You can see they've been added here. So let me save those 2 hollow cores. Just selection, select this one, and accept that. And I don't want to use existing mark, because if I did that, then it would update all the other HC1s to also have lifts. But maybe I want to do that, so maybe I should have clicked yes. But let's just go with this, and let's not use an existing mark as well. So those are now HC4s. They're saved to the database, and if you go back to the project manager, and if I update that, yep, you can see immediately that the numbers on those hollow cores were updated. Right, so those are our HC4 hollow cores. Okay, with that done, go back to the drawings. Yep, let's maybe select this column to see the drawing, and let's open the column drawing. That's a C1 column, so let's select this one. So I am getting a preview of the drawing. What do I get in the drawing? That depends on the template that I have. Maybe I just want like one view. In this particular case, if we go to the drawing, the layout, we get the B sections for some reason doubled. Might be some issue with the standard. Let's check another column. Let's select this one maybe. Yeah, C2. Yeah. Okay, this one got 1 for some reason. So there was some duplication of the section there. Of course, curse of the live demo. Yeah. So what we get on this drawing is just one view, like with the reinforcement, a view with the dimension lines for the geometry, and another view as well as like small sections with dimensions. Now, if we go back to the layout, not the layout, but the model, we can add the corbel reinforcement as well to this drawing. So let's do that. There's a tool for that. We'll just select the corbel. It will automatically recognize that, hey, that's a corbel. It gives me a small little preview of the reinforcement that's in the area, so to speak, for this. And I can decide whether I want the main reinforcement of the corbel and what type of reinforcement I want. So in the preview, you can see the bars that are going to be applied there. You can specify the dimension of those bars as well. So say it can be bar size 12, maybe 16 will be more reasonable for this type. And then the other type of reinforcement you can have, like horizontal bars, other different types of reinforcement. There are other types of that we have predefined in here. Let's maybe skip this one, but for the secondary reinforcement, let's go ahead and add some horizontal bars. We can change the spacing on that. I can, of course, well, not of course, I can, for example, rotate that view as well, so I have more clarity on what's happening. So let's change that to maybe 55 on the first dimension. Right, that moves down, and let's maybe go 65. Oops, 55. Let's go 65 and 65. Yep, that looks better. That looks better to me. So we can leave it like this. And for the other, like reinforcement, of course, there's multiple ways you can add that corbel reinforcement. As you can see right now, there's really a bunch of reinforcement. Like if we want like stirrups going this way, and sure, you can do that as well. So multiple different ways of adding the reinforcement. Let's go with those 51 shapes. And if need be, we can also add some dowel reinforcement just to demonstrate that. So that's a bar like this. If we didn't have a lift here or a connector here, then we could add this to maybe add a hole to the beam for connection. That's a thing that I forgot to demonstrate. We can go back to that in a second. We'll refresh the drawings anyway. All right, so let's forego this and let's accept that. So reinforcement has been added to this particular element, but I'm also asked if I want to add this type of reinforcement to the other corbels and the remaining elements in the project. I can click yes. I can do this like so and accept that. And I can replace any existing corbel reinforcement that's in the model if it was there. That's how we can add reinforcement to our drawing. We get the dimensions for it. We get the specification for that. I can refresh the drawing now. Under the MTO section, I can refresh the drawing. And with that, the drawing will be regenerated. And once it's regenerated, I'll get the updated schedule of reinforcement, like so. So basically all the bar shapes that were created for me in this are now shown here with the dimensions of the legs and whatnot. So yeah, that's how we can create this reinforcement. I can save that drawing right now. So just a second or two for it to save. It's going to be nicely available in the database. And that's saved. Let's go to the floor plan. One thing that I, fortunately in the rush and all the emotions, forgot to demonstrate, I want to, for example, create an opening for this lift, so I could possibly connect those elements. So how to do that? Easy, really. Let me select that. This is B2, so once I edit this, all will be edited as well. I need to go to ends, and I will need to create a circular opening at the end, and it's a matter of specifying the diameter. So let me measure first, so it will be easier. Dimension, let's measure that. So 170 mil from the edge to the center of the opening. And I also want to know the diameter that I want to have, 22.5. So 55 for the 55 millimeter opening should be good. So let's do that. Properties, like so, ends, circular, as we measured, 170 this side and 55 here, and let's copy that to the other side. Let's add that. Let's update the lifts. As you can see, the element is modified. It's now yellow, and I can exit and save. I can use the existing element mark like that, and if we zoom in, all the other elements, because I changed just this one, or they're B2 and use the existing mark, then the elements have been saved. And since they've been saved, then they've been updated in the database, and all of them have now the applied opening to the for the lift or connecting element. So we can go back to the model. We can refresh that. Once it refreshes, I'll just zoom in on that spot. Yeah, there it is. There it is, ready for joining of the elements. Of course, we can go back to the AutoCAD, and we can refresh the drawings for the beams. So let's select this one, and since the drawing was created without that opening, we need to refresh the drawing and reinforcement and whatnot. It will be quickly done. It's just one drawing for all those elements, so it will be quickly done for us. Once it's done, just a matter of opening that drawing and verifying that everything's okay. And there you go, there's the opening. There it is, added, visible, and the opening. If we go to the drawing, we have a section view, we have a view of the reinforcement and the dimensions of the elements, as well as like the dimensions of the element from the top view. Okay, so I would guess that would be everything for this webinar. Go ahead, if you have any questions, post them in the chat or email them directly to me. I'll be sure to get back to you on that. And with that, let me just go ahead and share a couple of useful links for you. So either our LinkedIn, let's do so the official, our YouTube channel, or the official website. Go ahead, have a look at all the info that we have there. And again, thank you very much for your attention, and I'll see you in the next webinar. And we will focus on walls then. Sandwich walls, sandwich panels, solid walls, all that fun stuff. I'll be filling in the gaps between columns, creating some additional structures. So that will be interesting. Show you all about it, and yeah, see you next time. Hi everyone, welcome to our today's webinar, a second part in the series of 3. Today I will tell you all about walls and slabs, particularly about solid walls and sandwich panels in impact, as well as solid slabs, as you can see in that preview window here that we have available. We will continue on the model from the last webinar from a month ago, where we focused on beams, columns, and hull cores. So, moving on, today's agenda will be consisting of modeling solid walls, sandwich walls, and slab elements, as mentioned before. We will also create wall joints, so selecting end caps and particular cast-in materials for elements. We will also use cast-in material templates. So this will allow you to place multiple cast-in materials at particular end plates if you don't want to click through joints on every element junction. I will also demonstrate how to create reinforcement groups in elements. After that, we will save elements to the impact database. We'll generate shop drawings, because to generate the shop drawings we need to first save elements into the database. And we will preview the elements in an Impact Project Manager. This might come before, or rather just after we save the elements to the database. So without further ado, here's our project. That's the model. That's the model that we had from before. And with that, I'll just open up one of the drawings available for us, the floor plan. I already have that open. I've opened that in the background, so we didn't have to wait too much. And with that, let us go ahead and start actually working with sandwich panels. We'll create a small building on the side of that big storage facility or factory of sorts. So under the tab walls, basically what we'll do is we'll click on the create or draw wall icon, and we'll select what type of wall we want to create. For me, I want to create sandwich panels. And like that, I immediately can start placing sandwich panels. Okay, so first I would like to place sandwich panels from this corner of the column to the other side, and I'll do it like so. I'll snap to one point. Important thing of note is first the direction we draw in. As you may see, if I go to the right, there's an arrow on the top of the wall as we look at it, and opposite to the unmarked text that you can see, right? This basically marks where the internal panel is for our sandwich panels, right? If I go counterclockwise, my internal panel is basically down on the screen that we have right now, okay? If I go the other way, so say clockwise around placing the walls, then the internal panel is on the outside. So basically this little arrow indicates where the inside of our building is for sandwich panels, right? I don't have to change anything since I'm going this direction, but what I want to change is the alignment of the wall. So I will just press LE on the keyboard as per tooltips on the bottom, and I'm good. I place the wall on the left side of the placement line. So I'm just going to click. You can immediately see, I'll press space for you. You can immediately see that the wall is marked red. That means it's too big. We have settings in Impact. They mention that if an element is too long or too heavy, it will give you such a warning, right? So the warning is red, so something's wrong. I'll continue on placing some other elements, and let's just press space, select sandwich panel. One thing of note, I didn't show that with the first wall, but if I press P, I can change properties of the wall, the sandwich panel. So I just have the sandwich panel of thickness 34 in my project. That's perfectly sufficient for us and for the demonstration. I could import more from our global database, but I don't need them. So we don't have to do that. There's a couple of levels for the standard that you have. There's the overall, say, common standard. So that's company specific, company wide. There's also local, that's one level below that. And the most compact standard is the project standard. Maybe you don't, maybe your factory creates sandwich panels 30, 35, 36, 37, like every centimeter thickness, right? But for one project, you might just need 34s, or as in this case, or 40s, or just those two, and you can import those two. So it will not muddle your selection while placing those elements. For me, I'm just leaving it as is, as sandwich panels thickness 34. I'm going to cancel out of it. We can also automatically select the end cap. So if I wanted to have a specific end to particular side, either left or right of my elements, or top and bottom of my elements, I can specify that here. For now, I will select none, because the end caps I will be automatically updating while I'm doing connections between the walls, and or splitting the walls from them being too long to smaller segments. Okay. I can also specify lifts and bracings. So bracings on the face of the internal panel, those are also visible here. They're automatically placed and they're placed by definition. So in the definition of this wall, I have a specific set of rules that define what type of casting material is for those bracings, what's the placement method. So in this case, it's placing by elevation and part of height, right? So that's basically proportion of the for our height of for our bracing elements. And where to place it? Well, do we include center of gravity for that? And same thing for the lifts, right? We can specify the type of lift. The lift definition is either by definition, so defined by the type of the wall that it is, or we can specify that manually, which unlocks all the settings. So if we don't want to think about that consciously and we just use one type of a lift for particular types of elements, then by definition is perfectly fine. But maybe for some specific elements, there are some project constraints that you have to abide by, then you would go and do that by user, right? And that's for the top edge and the other edges if there are any applicable. There's also possibility to add some specific casting materials and recipes for that, but we won't be focusing on this particular functionality today. And the last tab, model tab, is the placement of the walls. In my case, I'm placing them on the first floor, which is 3 meters high, and I'm placing the walls on the 0 elevation. If I wanted to create like a second floor of our walls, I would change that to floor number 2 and change the base elevation of our walls as well. Because this is assignment and this is the elevation of the elements. All right, so let's go back to general. What's more, there's reinforcement templates, which I will talk about briefly later during the webinar. And we can also specify how the panel is placed during production. So inner panel down, and yeah, that's it. Also a override for height for our walls. I'm going to accept that. One thing of note, my internal panel now is on the outside of the building, which I don't want. So what I do is I rotate that by inputting RO and pressing space. My text is now upside down, doesn't matter, I will flip it later. But our internal panel is now on the inside as I want it. What I also want is I want to center the wall on the axis. And like that, our wall is placed. I'm gonna undo because this wall is too big for my taste. That's gonna be too much clicking for us if I place too many walls, so I'll just skip that. So I undid that, and I'm going one by one by clicking on the elements. Right, so those are our sandwich panels on the outside of the building. They're too big, they're all in red. Right, one thing that I'll do, which will be slightly easier for us, if it bothers you in any way, you can edit this wall and just say flip, which will basically turn the text around for you to change the orientation, so everything is nice and clean on the drawing. Right, so let's continue, and with that what I'll do now is I'll split those walls. There's a split vertical command and split horizontal. So we are working in a plan view now, so I will split walls vertically. I will slice them right from the top view. But if I worked in an elevation view, then I could create like one massive tall wall throughout the whole building and split it horizontally. So let's do that. I'm going to select this panel and this panel. This way I can divide them immediately, both at the same time. I'll specify a gap of 10 millimeters, and I will also specify an end cap. I could select none, which then would just cut the wall straight, but I want to create an end cap for us like this. Okay, so let's do that. And I'm just going to click here and accept that. You can see both the end cap has been applied and the walls, both on the top and bottom of the screen, have been divided. So let's do the same thing here. and here. And the gap is again going to be 10 mil, and I'm going to use the same end caps. And like that, I'm just going to click on that midpoint line, and our axes are done. Okay, so that's one thing done. What I will now do as well is I will actually create internal walls as solid panels. So this is our second type of wall. Right. And after that, I'll start connecting all the elements and showing you how it's done. Right. So first things first. First, let's model the geometry. This time it's going to be just a wall. I'm going to first start our wall from here, right? And end it here on the middle. As you can see, the wall is in red. It's too big. Right. Let's create another wall here. I'm going to do that here. On the axis, doesn't matter. It really doesn't matter that I'm not perfectly aligned. We'll fix that later, right? So that's going to be super easy for us. One thing of note, I'm just going to create auxiliary lines for me, very quick, just so it's easy. Same thing here, and perpendicular like that. Why? That's because I just want to divide those walls exactly in the middle of the span here for my convenience. But other than that, that's basically there's basically no other particular reason for me to do that. Right. So let's do that. Let's split up those walls. So I'm going to select this big wall now. Gap 10 mil, right? And I'll also specify an end cap. For those, I'll just use this type of end cap. That's a 20 mil thick wall panel. I'm just going to do that here, and I'm going to do that here, and accept that. Right, perfect. For this wall, I'll go more or less around the midpoint of this wall. Should be good enough for us. Gap 10 mil, same type of and enter, and like that. Now we have our walls placed. Right. I'll soon go over the connecting of those elements, but let's first click on one of those walls as an edit and select see the properties. So those are our solid panels, and as you can see, very similar window as it was for the sandwich panels. You've got reinforcement template, just the production and cast type, what type of cast type that is. Also the dimensions of or an already placed wall. We can specify end caps here. You immediately see that one has been selected for the left side, basically for this element, because it was automatically created for as between our elements. And lifts, bracings, very similar, basically all the same options as you can have. Again, types, I only have like a 20 centimeter thick internal wall, solid panel, but you can create multiples. We do have additional one in our standard, but you can of course create new ones, copy this one, multiple different thicknesses, and whatever it is that you require in the standard for those particular elements. All right, so one thing, I'm just gonna open up my cheat sheet on the side just so I don't get too sidetracked, because I like talking a lot. Right, let's exit that. Okay, so that's more or less okay. Now, first I'll show you the cast-in templates for our walls, and for that I'll just split one wall additionally in one place. Maybe this one. Let's do that. All right, I split this one 10 in the middle. That's going to be this one. Let's go. Let's put that more or less in the middle. Doesn't matter too much. The exact dimension. For the sake of demonstration, I'm just going to do that. So there's two ways you can actually connect the elements. One is the cast-in material templates. That's apply template here. Let's see what kind of templates I have. I have none, so I'll import some. Not for those. Yeah, no, okay. Those are, okay, that should be good. Okay, let's apply that. Nope, I forgot. I have to actually import them like that. Okay, so I'm importing all of those that we can have. And what I'm interested in is this one. And what the casting templates do basically is they look at the end cap that is available in the that is actually used as a connecting end cap for the element, and then applies a casting material that at a specific location, as is the case here. I can edit that, like move the casting material here, for example. As you can see, I'm moving the casting material in this particular wall. Let's go back to 60 as it was before, and let's accept that. And yeah, let's go back to that. And it looks for this casting material, which I now just realized that's a wrong end cap for me to edit. Yeah, that might be problematic for this particular one. So let me go ahead and do something else for this one. Yeah, I have wrong templates defined for our sandwich panels. So since I don't want to waste too much time on configuring that during the demo, I'll do that very simply for this wall. It will be easier to demonstrate that. Right, and again, 10 gap, and let's make it this one. Yeah, like that. Okay, so I'll quickly demonstrate how that works, and yeah, go back. So custom material templates, again, quick explanation. What type of wall I have here is for my 20 size wall. I will look for this particular end cap, which I just now applied for as I split this wall, right? I'll just open it and edit, and I will apply this particular casting material at this end cap. At this location, which is that green cross at this location, I can of course move that, say 50, and moves that inwards. 38 is sufficient, so it looks very nice. And of course, I can rotate that, move that further out. I can also change the angle at 45 degrees if we have some kind of connection like this. Well, let's leave it as at 90. And of course, the type of casting material, it can differ. We can change that to something else. I think we also have like a smaller loop. Yeah, we have a smaller loop for different types of connections. So, of course, casting materials can be added by yourself or by us. Not an issue, right? So I'll just accept that. And as you can see, we have different end caps because those templates we can define multiple different end caps available, and we can define what happens if this particular template detects any of those end caps. So let's have a look at the other one here. So that's this type of connection. And then what it does, it automatically places a casting material like this in this type of connection, okay? Like automatically. So let's accept that. And there's also different placing options. So basically for the placing options that you see here, let's go left. So the casting material that we see here, that it will be applied here, we can specify placing on the left and on the right of the wall. So both sides of the wall we can specify, and we can specify how those casting materials are placed. So that's basically the distance from the bottom, distance from the top, and the spacing that should be more or less conformed with. And there's different schemes also of placement of casting materials. So first, the distance from the top, from the bottom, from the top, and number of casting materials to be divided equally at that distance from the top and from the bottom. So I'm just going to leave it at the default values. It's perfectly sufficient for us for this 3 meter wall. We might get 3, we might get 4 casting materials, right? So I'm just going to accept that. And now what I'll do is I'll apply that template. So I will select objects. So those 2 walls, since I have those two types of splits here, and I'll just accept that. Right, and specify which template to use. I want this one. And as you can see, the program automatically created the connections between those two walls. All right. The other way of doing that, would be to manually. That's casting material templates, right? So we can select multiple walls or the multiple elements in the project, and with that, the program will automatically look for any types of end caps that are defined in that template and apply the casting material that's added to that. The casting material can not only be like loops here, but it can also be, for example, type of rebar or maybe channels for connecting other elements. Basically, any casting material that you can think of and create that within the AutoCAD interface and have a 3D model of, then you can use that as a casting material template, right? So that's one way. As you can see, it was very fast. If I selected all the elements, it could connect them and join them. Yeah, that works. That checks out. However, there's also a different way. It gives you slightly more control of what's happening at the moment, like immediately, right? And that's going to be the connect wall. So this is how we create joins. So that's one of the next topics of our discussion here. I would suggest using connecting wall at more problematic places. Like for example, here we have a sandwich panel connecting to a solid panel, and so is the connection here and here, right? That's a more problematic connection, or other more difficult one to detail. So it will give you more control, and I'll just show you how that works now, right? So I'll just select those two elements, and what will happen is the software will try to find the best possible match for this type of end cap to end cap connection. And in this case, it immediately suggests me this particular type of connection by weld plates. I can have a look at the other suggestions that it creates, and I can see that it also creates a straight connection with wire loops. So let's use that here. And I'm going to accept that. And here now I can specify the distance, the type of setup of the casting materials on the side of my wall. So I can, for example, increase the number of casting materials, right, in this connection. Okay, and I've now applied the casting material, and I can swap the sides, or if there's a different alignment possible, it will suggest it here. There won't really be a better alignment here, so I'll just apply and update all. So this will also update the lifts and the geometry. I can also now the command is not finished. I can select another collection of this type and just press space, specify your origin of the joint, and apply. And it automatically creates that connection for me, right? And let's accept that. Basically, it adjusts also the spacing between the elements if there's need for that, right? So basically, once you define the type of connection that you create, it's like a corner or a straight connection, then you can apply that to different places in the model as long as it's the same type of element connection. Oh, sorry. Let me get a drink. So, next, let's actually place this connection. So it will automatically detect that it's a corner connection between sandwich panels. I only have one type of connection like this defined, so this is the only one that it proposes. I don't have a wire loop connection defined for elements like this. So the weld plate connection is only applicable here. And to demonstrate how the preview looks like, see, I can specify which element gets extended. In this case, it would be this wall, and this would get shortened, or the other way around. So let's make the vertical wall here, vertical in view, the longer one. And let's accept that and update all. What happened now, as you can see, this element got red. It got extended, and it got extended enough that it's too big now to be lifted by our software, by the erection crew, or it exceeds our limits in software. I also select this corner, and I'll apply this particular extension, accept that, remove the auxiliary lines. No worries, we'll split those walls later, or just now, and you will see how easy it is to fix that situation. So this element is too big, fine. Let's split it, right? Let's use this particular end cap, right? And around the middle, and accept that, and do the same here. And same here. Like that. As you can see, very quick, very easy, and the model has been fixed immediately. Now, what about this? This is problematic, but still I have defined a connection like this, and let me just select that, and there's no suggestion on the type of connection. There's only one possible connection that I have defined, and that's a connection like this, and I'm going to update that. As you can see, it's done. What I do here, accept that here as well, and accept that here as well. Doesn't matter that I selected a beam, it recognizes that I'm working with the columns, and it automatically updated the connection like this. And it's done. This is basically more or less the what the placement of end caps and joining the elements together in sandwich panels. Of course, if we have a look at the 3D model, we now have a shape of a building, right? So that works. What we can do also is we can actually start placing some openings. Let's do that quickly, because it's a bit it's kind of hard to get in that building if we don't have any openings, any openings or windows, whatnot. So let me just do that. I'll just arbitrarily place a door like this, and maybe a window as well in that wall. So let's do that like that. So of course there's a command that allows us to create openings, but I need to first select the type of element, right? Like so as well. And I can have predefined types of openings available for me. There's more, of course, available. You can create more very particular openings, something that you would, of course, need or require, right? So let's undo that, because that was an unwanted click, and let's go and again create a door as well. That's gonna be this one, and let's place it somewhere here, right? And let's leave it be for now for our elements. Yeah, one thing about reinforcement, I mentioned reinforcement templates, right? So let's actually go and talk about those. There's reinforcement templates. I have two available. My walls, I think, have this one applied. Let's double click on that. So what happens is, for sandwich panels here in my reinforcement template tool, I can specify how I reinforce the sandwich panels. So I've got the double mesh, double rebar option. I've got double mesh, double rebar as well. It's a different kind. Single mesh and double rebar. You can see preview sketch, and you can get an idea of what happens here, right? Or just single mesh, single rebar, right? Let's go double mesh, double rebar. Let's cancel out and go back to the default one. Yeah, you can specify which panel is basically the placement where each layer of reinforcement is directed towards. Same for the outside panel, right? And you can also specify covers and offsets from bottom and top. You also have the edge reinforcement and corner reinforcement. available, and opening reinforcement if there's an opening in a wall. We will be able to check that out later. As well, some wall and column beams that can be placed on the drawing later. I might show you a different way of doing things like this. In the edge reinforcement, we can specify the spacing for the end cap reinforcement if it is specified for a particular type of end cap. So let's do that now. In Impact for AutoCAD, you don't really immediately see the results of your settings for like reinforcement. That only happens once you create the drawings. But that is pretty easy to set up, and then very easy to verify that all is good once you have the elements all specified and all the settings specified. What I'll do now is I'll create sketches of end caps that I have in the model, right? So for my vertical walls, I know that I have this particular end cap. So let's draw it, right? I'll draw it in the model space somewhere outside the drawing. It really doesn't matter as long as it's in there. I can delete that or make it smaller. That's just for preview here for us, just so we know what we're doing. Then I'll create another end cap. This time this will be a sandwich panel 1, and right, that's going to be 801, and that's also the one that we used for our splits in the walls, right? So I can add that in here as well. Just draw it here like that. Oops, it's a bit crooked, so let's delete that. Let's do that again. Yep. Let me verify one thing. I'm going to edit the wall, go to properties and select the end caps and see what kind of end cap was applied. That's 804. Okay, so that's perfect. We can still do that. So this is this particular end cap. So I'll create this end cap as well for us, and for it, of course, I can place the reinforcement. Yeah, while I'm here, a quick connection. Of course, the automatic connection between elements doesn't only work with solid panels. It also works for sandwich panels. So just very quick demonstration here as well. That, oops, like that, and apply, and yes, up they go. Right. So it works as well for the solid panels. Just FYI. Okay, now so let's place that end cap that we had before as well for the sandwich panels. It's this one, slightly different as you can see in the preview. Doesn't really matter. It will be very quick for us, very similar. Okay, let's go that, change that quickly, change that text to something smaller. Oh, for some reason I can't. All right, doesn't matter. Let's just move this one up. Sorry, too many clicks. Okay. All right, so now in order to get the reinforcement in, I need to go to the reinforcement tab, and I actually need to create a bar, and that's from the bars tab. What I want to do is I want to specify the dimension of that bar. I can make that a size 10. I also want to apply offsets. Offsets will be my covers, and I'll make that to be 25 millimeters. Accept that. Or maybe let's go and make that 20. I think 20 was set for the wall reinforcement. So my offset is like that. What I'll do is I'll just go like this, like this, like this, and like this. Oops, undo. Like this, and space. The size really doesn't matter at this stage. What I need to do is I need to edit this bar. Yep. And with that, I will manually update the size. Let's say 400 here, 400 here, which will be perfect, and 80 for this particular width of the bar. And that's it. What I also do is I'll delete the text, which we don't need. There's a bunch of settings that you can have here for representation in 2D, 3D. The steel quality, the dimension you can change here as well. The bend radius of the bar as well, you can specify here, or hooks if you need to create those at the end of the bar. So you can see in the preview here, small hooks available. Let's turn those off. And I'm going to accept that. And I'm going to move that bar. Right, I'm going to move that here and move that additional 20 mil like that. Also copy that bar and copy it here as well. So slightly different end cap, as you can see. What I will also do is I will very quickly create another bar for us like that. Click, click, click. I don't need to change any settings. Settings are remembered from the last bar. So let's edit that as well very quickly. First, let's turn off the text. We don't need that. General, let's go again, 400 and 400, right? All right, and let's accept that. And I will move my bar to here. 20, 0, 0. Okay. Yeah. Now let's go back to plan and let's edit the end caps, because this is where you actually edit the reinforcement in the end caps. I'll go and open up the first end cap. So that's the 801 end cap, right? And here I have some specification of the geometry of that, the extensive of the end cap, for the casting materials if they are placed any automatically, and the reinforcement. So let me select the objects for this particular end cap, 801, and let's select the reinforcement. And the base point, which will be this point. And we get the preview of that. And that's it. I'll just accept that and save that. I'll do the same for 804, select objects, like, oops, I did a wrong thing. It's gonna be not this one. Well, let me go back, because I've created too big a bar for this. Let's select the reinforcement, and it's gonna be this one. I chose the one for solid panel. Yeah, that works. Now this one, it will be the same bar really. Accept that, and for walls, you can see very quickly I can edit that. Of course, you would need to specify that for the other types of end caps as well if you want reinforcement like this. Since we don't really have that much time today to do that for all of those, I'll just focus on those 3, and that's it. Now, whenever we create drawings for our elements, if they contain any of those end caps, then this reinforcement will be applied. I could delete that from the model right now. It's no longer needed. It's saved in the database. That's it. It's saved. But what I would like to do right now is show you the reinforcement templates, right? Because let me go and accept those, and that's reinforcement. Let's say I want to add the end cap reinforcement, so I need to actually specify this type of spacing here. So top spacing stirrups, bottom spacing stirrups, left spacing stirrups, right spacing stirrups. So let's go maybe 50 here, 150, maybe 50, 150, 150, and let's see. So that's for the, yeah, so that's going to be the spacing for us, or maybe 200 will be better, right? So that's the setting for our end cap reinforcement, right? To explain what happened here right now, let's go and edit the wall properties. So the walls have assigned, so that's a different template, reinforcement template. So I can go back and edit this one. Basically, the reinforcement template decides on the whatever reinforcement is in the element. So let me go ahead and go back to this one, edge reinforcement. Okay, we already have some definition here for left and right side of the elements. Let's go make that tighter. 200, right? And let's save that. And that's okay. That's done, really. What I now want to do is I want to show you the panel thickening, because I want to place some slabs and I want to place them on some panel thickenings. So let's do that. Maybe in this section here. Now too many walls. So let's maybe do that here. Yeah. Okay. So what I'll do here is I want to create a panel thickening. So I'll just click on this, sorry, not this one, draw panel, click thickening, and I will select an element, right? So I can now specify the height and thickness of any panel thickening and the placement of that. So if I need my panel to get thicker, for example, on top to create a support for something, then I can do that here. Right, so let me draw that. Height 150 should be sufficient, thickness 100 should be perfect. So let's go and do that. So I selected the element, and what I'll do now is I'll start from this point, and as you can see, it grabbed my panel thickening in a wrong place. So let's do that again. Wrong snap, basically. Yeah. So let's snap to the edge here. Perfect, right. That's perfect. And I'll go and I'll reach this point, right? And yeah, that should be good. I'm going to space and accept that, update all lifts, and let's see in the 3D model how that looks like. Oops, so basically for some reason it's placed out on the bottom for me. So let's nothing bad happening. Let's just edit that, select thickening, let's edit that. And for some reason it didn't choose the proper elevation. So I know my elevation for this should be 208.50, and that should be good. Let's accept that and update lifts. Yep, that's perfect. That's what I wanted. Let's maybe add panel thickening as well for this wall, just so we're consistent, right? And it's going to be the same thing. And let's accept that. Okay, and let's do that from this point. Right, and you can see the preview. Maybe working in 3D is slightly better for this. All right, let's snap that to the bottom, and like that. Like that, we have a panel thickening. Let's accept that, update lifts, and now we have panel thickenings, which is perfect, because now with panel thickenings, I'll show you later how to add reinforcement to that on the drawing, but now let's actually place some slabs for us. So slabs, very simple. We have an icon for those. It's again a bunch of settings that you can have. Definition, I just have one type of slab defined here, a 185 mil tall slab. That's it. And also 150 mil balconies. But of course you can create your new slabs, new, accept that. And you have a bunch of different settings for geometry, like width, the tolerances, the element thickness, concrete material, end caps applied as well, lifting, connection, and other elements. I'm just going to cancel out of that because I don't need to do that. And let's go OK. So for the slab, end caps you define while placing the slab, right? So we'll do that a bit later. For model, you specify basically the placement of that. So let me change the elevation of that to 3000, because that's the top of our walls. I don't want to move my slabs later. That should be sufficient to change that here, just to make sure. Of course, it snaps to whatever floor you have according to the settings and the placement, if it's by the top or something else. And again, reinforcement template for slabs, it's a different one. So you can define if it's meshes or bars, spacing of bars, etc., of course. So that's where you, so you'd go to that reinforcement template thing and change the reinforcement there for slabs. It automatically applied while placing the elements according to the template, right? So let's accept that. And let's place those multiple slabs, and let's place them by a window, right? So let me select that, and I'm just going to grab that by this point and grab it by go to this point. Ugh, it creates one big slab for me. No, it doesn't. What I'm now asked for, as was the case for hollow cores, I'm asked to add support and possibly change an end cap, right? So I can have different types of end caps specified here, or just plain straight end cap. So let's do that straight end cap here. Let's copy that to next. It's already extended by 80 mil for supporting length that I specify. I can copy that to next. This one I don't want to have a supporting edge because it's a free edge of a slab. So let's leave it like this, and let's go to the next one. In here I'll change the end cap to maybe an end cap like this with a 100 millimeter support, and let's copy that to the next one as well. Yeah, and let's accept that. I don't want a slope, and I can now divide that slab, or if I want I can rotate that, but of course we don't want to rotate this slab because there's no support on this end. Let's do that and accept that. I can of course move the cut edge if need be. Let's make it that free slab, and like that it's all good. If I go to the 3D model, it's placed on our thickenings for the panels, right? Yeah, so that's the gist of it, of very quick modeling. Now let me go ahead and save everything to the database. And once we do that, we'll look at the 3D model that's been updated, and after that, we'll just go ahead and start working our way in the reinforcement drawings, at least a bit. All right, so to save the elements, we go to the Wall tab, we select the Save to Database option, and let's select all slabs. Automatically, let's first save the sandwich panels, right? Let's save those. So I'm now saving those with a element mark SW1 as the first one. I'm waiting for that to go through, and as you can see, it went through. It's okay. I'm going to again save to database. I just press space to repeat the command. Save walls, wall panel 1, WP1, sorry, and let's save that. Good, that's all saved, and let's go to slabs now, and let's select all slabs S1, and we have 2 slabs here in the model, right? So that's good. Now let's go back to the project manager. That's our impact project, and let's update that. Boom. Here is our 3D model, and as you can see, we also have the panel thickenings here. Let me rotate that. Available, visible, the end cap here visible, end cap visible on this slab as well, and a straight end cap here that we extended by 80 mil onto that slab, and we can also see the extensions of slabs and whatnot, of course the openings as well. Right. So that's our model. Now let's go back to AutoCAD, and in the AutoCAD I will now create a couple of drawings. Let's say I will create, yeah, let's not go overboard with the drawing so it doesn't take too much time. Let's create drawings for, say, this wall, maybe. Let's create one for the one that has a panel thickening, so maybe this one, and it should also apply the end caps as well for us. Other end cap reinforcement, yeah, so maybe those 2 walls, because this will go fast for us to have a look at and edit and play around with. Yep. Oh boy. Okay, so those drawings are now done. Let me create drawings. You can't really create drawings at the same time for sandwich panels and solid panels. You have to do that separately. So let's go create maybe here, maybe this one. Yeah, okay, those 2 are simple enough and should be also quick. Oh, I forgot to create a connection here. I hope you forgive me. Yep, that's quite all right. Okay. So while that's thinking, we'll also, after that, we'll also quickly do the drawings for the slabs. So we'll see, or maybe we'll go to the reinforcement template for slabs and see what's set up there. So maybe we can change that and still, you know, update, change the drawing slightly. So all's good. All right, so let's go to reinforcement templates and let's go for slabs. Import those, import, okay. Let's see what's in there. Okay, so that's basically double mesh, double rebar. Yeah, that's gonna be double mesh reinforcement for the slabs. Yeah, if we had end cap reinforcement, we could do that, but I didn't create that for this particular type of slab. Let's quickly create drawings from the slab section. You have to click the slab section. One thing we can very quickly do, we can create opening in a slab. Let's select, say it's going to be this slab. Let's create a cutout and let's do that. Rectangular opening, say like this dimension, and yeah, I can update lifts, and I need to also update the slab. And slab. Use existing element mark. I will use the existing mark, so it will still use that S1. It should automatically apply some opening reinforcement for us. And that's it. So let me create a drawing for a slab. Let's go for this one, accept that. The other one will skip. So, you know, it's a slab, pretty simple reinforcement, but you get the idea of how quickly that is done for various elements. Yep, the drawings are done. So let's open the wall drawings for whichever walls we have. I'm just going to select the ones that we have. It will automatically open all the drawings that were created. So this is, I think, 4 drawings for our walls. So we've got 2 wall panels, two solid wall panels, 2 sandwich wall panels. Yeah, we see something there. Yeah, that's that. And let's open that slab as well. Slab. There's so many icons, sometimes I have a hard time finding the proper one. All right, okay. So that's the very quick automatic drawing of a slab. We can also create a 3D preview of that. There's a section view as well for the slab, both the longitudinal and transverse. Of course, we could work with adding some reinforcement to openings. Need be, there's tools for that. So no problem there. Maybe we can try doing that. Sorry, this comment is for walls only. Draw template proposal edge. Okay, so maybe we'll forgo that for now. We have some other stuff to show for sandwich panels. So to quickly demonstrate drawings that we get. All right, so here we have a bunch of stuff. So immediately on the drawing, there's some reinforcement that's shown. There's custom materials that were placed in that wall automatically while we were creating connections, and as well we also have that edge reinforcement that's been created, right? So we can convert that to a reinforcement group, or we can leave it as is, as 16 B10 bars at 20. So we specified that distance 20 centimeters, 200 mil. We can convert that to a reinforcement group. So I'll quickly show that. Convert reinforcements to a group like that. Let's leave it like this. This will basically create a group for you, and you will skip some dimensioning here. And if I go to element and refresh the reinforcement, this will refresh the reinforcement in a drawing, which will show the reinforcement group that has been created. and it should also update the schedule for that, right? So that's our group. So that's the bars that we created, 480, as you remember. That's the bars that we've specified to be in the end cap, and those are also visible here. So this is also automatically created while rather applied when creating that end cap. And of course, the same case for the sandwich panel that doesn't have any openings but has a panel thickening, and that panel thickening is here. If we go to that view here, here's a different end cap. It's a straight end, and here we have the WD34801 end cap and the reinforcement of the end cap as well. We also have that panel thickening. Of course, we can edit that panel thickening here. We can move this line here slightly, and we will then edit the geometry of that panel thickening. So we can do that. I can go ahead and make that shorter, but I need to regenerate the geometry of the drawing as well. So I'll do that. And after that, I'll show you how we can add reinforcement to that now on the drawing, right? So it can be applied, and yeah. All right, so the drawing was recreated, and you can see the thickening has been changed, right? Just a matter of now, the thickening is not automatically so basically the dimensions don't automatically detect that there's a thickening there. So the dimensions you have to move away by hand, but that's as long as most of the work is done for you, it's all good, So let us do that reinforcement. So what I want to do is I want to draw a reinforcement group. Okay, so I want to draw a reinforcement group. I have none available here. I would have to create a new one, but thankfully I can import some that are already existing, and I can play around with those and edit those. I don't even need this one really. No, let's cancel that. Let me just import this one and accept that. I just need this one, and that's okay. And I can specify this. So you can immediately see the preview of that reinforcement group and how it will be placed in the panel, right? I can change things around slightly to make it fit into that panel thickening. I know that panel thickening is 150 mil high, and it's 100 millimeters of a cantilever over the wall, right? So let me accept that, and let's verify those dimensions in a section, right? So that's gonna be dimension, that should be 100 mil, which it is, and the height of that is 150 mil, which it should have been, right? So we can go ahead and actually do that reinforcement. Let's draw that group. I'm going to change that. I'm going to configure whatever I have here and change that slightly. So I want to change that shape. I want this to be, so since we have about 200 millimeters of a panel, I'm going to add here 170. Okay, that's that. And for height, since this is 150 of height, so let's make it 110 maybe. Yeah, and let's add more reinforcement here and here. Okay, also let's add hooks to that, so it functions more or less better. There's quality of bar, the dimension of bar. We can maybe make that a bar size 8, so it's slightly bigger. And I'm going to then change the placement of that to say bottom right. Okay. And the rotation, I don't want any, like that. So you can see this is a preview. The preview, of course, does not include the panel thickening, so don't worry about that. That's because you can place it anywhere on the height of the wall, which will be then automatically reflected on the section, right? So let me do that. Let me now change that offset slightly, so maybe to 20. Yeah, that's too little of a difference. To 35. That was 225, so let's create more of a cover here. If we create more of a cover, that's going to be like, say, 25. Let's go 250. That should be sufficient, and let's accept that. So now I have my group properly horizontally spaced in an element. It's just a matter of now placing it properly vertically. So I'll start it from this place to maybe this place, and 0 anchorage, because I could specify the anchorage so straight bars would extend past the start and end point, and I will not round that off. And as you can see, I now have that group placed, but it's slightly off. I still need to move that. So let's move that vertically. So it's not exactly on the line. Let's move that by 25. Let's go displacement. Let's go 25. Okay. That's gonna be delta Z 24. Okay, should be sufficient for the demonstration. It should be perfect. And let's refresh the drawing now. What's going to happen is this is going to be a group of reinforcement. It's also going to be detailed on the side, so you will have that group nicely detailed. But while refreshing that drawing, I'll also refresh the section where the section will be visible for you, or where the reinforcement will be visible. So as you can see, we do have that group added here, right? And we also have the group visible here for us. All right, so that's the group. Group is called A2 because it's a second group in the drawing set. And as you can see, there's also the unconverted edge reinforcement, which I can of course now change to group as well. So let's convert reinforcement to a group, right? Let's go leave that like that. And I can again refresh drawing and the material takeoff. Here's the material takeoff. I'll zoom in once the drawing updates for us with that group visible, and I'll go ahead and also create a 3D view of the reinforcement for you, so you will be able to, you know, see the reinforcement more clearly in 3 dimensions in AutoCAD, or to place it on a view. Okay, so here's the schedule for the bars that are bent, and where's the reinforcement here. So here are the groups, the A1 and A3 groups available, the number of those groups in the element, total lengths, and the groups dimensioned, right? So you have the dimensions of bars, you know how to bend them, all's good. Right? Again, section view, you have this visible for you as well for the end cap reinforcement. Now in here, there's, as was the case for the columns, there is a 3D model of the element. I can just click on that icon here. This is a changing for a solid reinforcement view, and for the preview, I want to include the reinforcement. I want the cast-in material as well. And like that, I have a 3D view of reinforcement. So that's the panel thickening reinforcements. You can verify that it's there. There's also the no, that's not this one. That's the inner panel additional end cap reinforcement for you as well. So if you go to the reinforcement view drawing, you've got all the reinforcement, you've got the groups, you've got the schedule, you've got the 3D view as well, and 2D views for inner and outer panel. And in the main drawing, you also have the 3D view, of course, maybe some adjustment to the viewport, but you've got the end caps that are created with this. You've got the formwork view, formwork drawings as well available. And for the standard panels, well, you can see in the drawings the wire loops, casting materials, weld plates that have been placed. Wall panel 6. Wall panel 6. Did we? Where's the end cap reinforcement? Yeah, that's basically the automatic drawing creation for you. You also have that preview, can add the reinforcement in that. Yeah, I think that would be it for today. Actually, we've covered a lot of topics in quite a bit of detail as well. So yeah, with that, I would like to thank you for your attention. Let's go back to the model. We've done a lot in terms of modeling, in terms of connecting elements. So we've created joints, we've used casting material templates, we've talked about reinforcement templates and reinforcement in the end caps, how to add stuff to end caps. We've generated shop drawings for our elements, right? So there is a ton of stuff that we've covered in this video. I'd like to thank you all for your attention for this slightly bit over an hour. With that, I would also like to invite you to our next webinar. And you can find out about it on our strusoft.com/webinars website, or you can just go to our main website, go to resources and upcoming webinars. And the next part, the part 3 of this series, will be Precast Detailing and Impact, part 3. I will focus on form slabs, double walls, and linked elements, so your staircases or other types of non-standard elements. And for if we have any Polish viewers here, then be sure to check out the part 2 of a Polish version of this webinar. I'll be doing that as well in a couple of weeks on November 8th. So not far off. I very much would like to invite you all to that. And also, as well, I would also like to invite you to our LinkedIn site, our Strusoft, either Strusoft official or Strusoft Polska YouTube channel, and to our official website, as well as the wiki for Impact, which contains basically everything that I've shown you and way more stuff than I'd be able to cover in any single webinar. So again, thank you for your attention and see you in the next webinar. Hello everyone and welcome to today's webinar. Welcome everyone who joined. I'm very glad you're here. Today we'll talk again about precast detailing and impact. We will be focusing on form slabs, double walls and linked elements today. And of course what we'll be doing today exactly is we will be modeling double walls, and on top of those we'll be doing some form slabs, and we will be adding some linked elements in as well in the form of stairs and whatnot. We will show how to create and edit wall joints for double walls. We will be editing some girders and elements. We will be saving all the elements into the impact database, and of course generating shop drawings and previewing the 3D elements in Impact Project Manager. So with that, let me go ahead to the project manager and show you the model. So this is like the start model. It's been built in the series of webinars. Already what you see here, the leftmost part, is beams columns that were created previously in the first webinar 2 months ago, and the rightmost part about sandwich panels and slabs and solid walls, that was created last month. So we already have a model created, more or less, and with that I'll be actually adding some more elements into this model from within the from the basic floor plan of this whole thing. So this is like the AutoCAD view of that, and in here for today's session I've prepared some guidelines so the modeling goes a bit smoother. All right, so let me go ahead and go to the top view, and with that we will be focusing on this area here today. And this is just an outline of the for the double walls that I have, and with that I would also like to mention that we will be doing some linked elements as well. So here I have a sketch of stairs that we'll be using in that. What I'll do now is, for the sake of clarity and better snapping onto points, I would just isolate this particular area of the model for us to work on today. Okay, so for your information, in general, for all the other types of elements in impact, so your beams, slabs, walls, columns, and hollow core slabs, you will be using the plan ribbon tab, all right, because it contains all of those components here. For form slabs and double walls, we have separate tabs in the ribbon in AutoCAD. And today we'll start with double walls. And for those double walls, I would like to direct you towards double wall definitions first under double wall section, because here we have the definition of the available double walls in our projects. In my case, there's only one, 200 millimeter thick, with the definition name of DW200. And I'll edit that. In here, what we see is the basic properties, or the basic information about the double wall type that we have. So both the width of panel 1 and panel 2, so the internal and external panels, and we see the total width of the wall. So important information for us. Okay, basically the internal void between panels is created as a calculation of a subtraction from the total width minus the total of the two panels. You can also define the material. So one panel can be, for example, concrete. The other panel can be maybe lightweight concrete or something else entirely. That's all up to you. We can also create end stops, and we will also be able to add end stops at other points during the whole modeling phase, which I will be mentioning if I remember about mentioning that. But yeah, so if you don't want to remember about adding special formwork or something to keep the concrete inside, then you can just model end stops with your double walls as well. And next one is lift and bracing tab. In here, basically, you can define what type of lifts you use. What's the maximum allowed distance between lifts? What's the spacing if there are more than 2 lifts, so 2, 3, 4? What's the default type of a lift? So basically just input the name of whatever lift type you use, whether the lifts need to be rotated, and the number of lifting points, and what type of lift is used depending on the mass of the elements. So for example, we don't have anything defined for one lift. I think it would be not practical in terms of walls. 2 lift points, more stability to that, and we have 2 definitions for max weight of the element. So elements up to 2.5 tons, that's lift number 143, up to 4.5 tons, and that's lift 145. And 4 lifts, that's the second lift type, so 145, but we have 4 lifts for elements over 4.5 ton and less than 8 tons. You also can specify the bracings. So basically, once you place this wall, you brace it to a slab or a foundation of some sort, and you have some rules on how to place the bracing points in the wall as a part of height, or maybe that's a fixed distance. Let's use that part of height. And yeah, and you also the placement of along the length of that, and the type of the bracing point in a wall that's available to you. That's also here. Next step allows you to specify the reinforcement for the panels. So reinforcement tab is about loose bar reinforcement. So you specify what size of the bars you have, and the horizontal and vertical spacing of those bars, as well as concrete covers. And mesh is the reinforcement for the just mesh reinforcement that you might have and use at your factory. So that's in panel 1 and panel 2. And the way you represent this mesh in the drawings, it can kind of be as a area, so basically the diagonal line across the view of the element, or as bars. But if you use both the reinforcement and mesh, in loose bar reinforcement and mesh in your panel, then maybe the bar representation might not be the most clear. With that, you can also specify the layer on which side of the mesh you are using in which view. Next section is the lattice girders. We will be actually moving those around maybe later during the day, and in here you specify the spacing of the type of lattice girder that you use between those two panels, So in my case, it's 300 mil, and the maximum allowed distance from edge are the minimum allowed distance from edge and maximum allowed distance from edge. If you, for example, split a wall at a point, it might so happen that one of the girders will be, for example, closer to the edge than the minimum allowed distance. Then that girder will be marked red for you, so you will know that you can move it about. Okay, so last tab, basically just some overall view settings and some the way the information is stored in the model and how it's how the properties are set for the lines and blocks of views of the elements, and that's it. So I'm going to accept that, as well as I'm going to accept the definition, either go out of the window. And with that, let us actually start modeling. So I'll do now, what I'll do now is I will click on the start point, and I will specify a clearance at the start of the element. So I'll set it to 10 millimeters. You will be always asked about that while actually creating elements. So what happened here, once I zoom that out, so from the point that I clicked as the origin point of the wall, you see this large red circle. This basically gives you an immediate idea of the allowed size of the element. This is the max size of the element that you can get without still within the acceptable range that's set in your project settings. So basically you can produce that and you can lift that element out of your table or form. If we exceed that, the software won't stop us, but the element will be marked red, that it's too big and it needs to be split at a later date. So let me go ahead and play around with that a bit for you. So first things first, with while pressing certain letters on keyboard, you can change the alignment of a wall. So for example, if I go right, you can see the alignment has been changed. If I go L, I am now aligned to the other side of that white line that I've drafted before, and C is for center. And we'll go center here for this particular spot. What you can also notice is the arrow and the text unmarked, and that shows you the internal side, or rather the side which you can brace, basically internal side of a double wall. So you can switch that with an S and a spacebar on the keyboard. So let's actually do that here like this. Okay, and what I'll do now here, I can go ahead and click here, and you see the circle, the red circle actually moves about once I click through points, right? One other thing, you can see that the joint between those two walls is automatically created. If I don't like the alignment of that joint, I can change the priority by selecting this option or pressing I on the keyboard, and you can see the priority change. So basically which side, which wall covers which end face of a panel from which side, and like that. But now I don't have to click at every single point like this. I can just go straight to the end, straight to the end, and straight to the end. One other thing, you can also press P as properties. And here you can specify, for example, the height of the wall. For us, it will be 3000. It's going to be fine. And I'm going to accept that. And I'm going to click at the end. And I'm going to press space. And now I'm asked about the clearance at the end of the set of those double walls that we have. So I'll press space or rather enter. And I immediately see that 3 walls, which are very long, have not been gave out the warning that they're too big. Okay, and they're too big. If they are too big, then it's just a matter of actually splitting them. And to split them, we use this option. So let me select a wall, clearance between the walls, and click and click like that, and walls are now split and divided, lifts are added, all good. So I'll do the same for those walls, split, split, okay, and the last one, then split and split, enter. Everything's green, everything's okay. There's no red girders, which means that the girders are placed correctly. We didn't split anything in a silly place. Let's actually finish up with the other walls as well. So let me create those walls, and for those, we can go. You can, for example, go here, make it smaller here. I'll explain why I'm doing that a bit later. Clearance at end, which is good. And last walls, again, start and end, like that. And that's good. And with that, I can also copy the walls with standard AutoCAD commands, so I don't have to draft everything manually. And I can also use a mirror tool, so I can copy those walls to the other side, right? But maybe before I do that, before I copy those, let's focus on actually editing those walls slightly. So what I mean by that, for example, here, that's the start point and my end point of the whole placement of the external double walls. With that, you can see that the joint was not properly created. It doesn't do that automatically once, because that's basically start point, end point. For the intermediate clicks, so once you have this one and this one as a start and end, then the software actually knows that it's a corner, so it does that. But that doesn't bother us too much. We can quickly fix that. So let me just have a look at this end. Okay, those panels are on top, so let's do that. I can now easily edit the length of the panels. So let's do that. There is an option here available, which will allow me to edit the panel lengths. So let's do that for this. Now, let's actually edit both panels. Move it here, and let's actually move that again, both panels. What I'll do here is just move that 10 millimeters, so we have the nice spacing. And you can see that the girders move as well. So that's good. What I'll do now, I'll just extend the second panel, so this one, and I'll move here. And I just moved one panel. What I'll do here, I'll move now this panel. So this panel 1, move it to here. Oops, I wasn't supposed to do that. I was supposed to select this one and actually move it just to this edge. Yes, so that's good. And now just this one, like that, and move that by 10 mil back. And now we have a nice little connection. And of course, if for some reason I need to change the priority of that joint as well, there's an option here. I can just select that, and it will switch that priority for me for this wall. So even though it's not like an automatically created joint, the software still knows that, yeah, switch panels, basically. Okay, with that, let me go ahead and, for example, create a connection between this wall and this wall, because this requires a T connection between those. So let's do for that. Let me select those two walls, like so. And I have a bunch of options here. So it automatically detects that we have a T connection between double walls, and we can either create a slit, we can create an open hole throughout both panels, or we can, add a U-bar and a slit for different type of concreting, different type of connection. For us, I'll just use a slit and not make it a cut through throughout the whole height of the panel. So it's just going to be a slit in a wall, which we'll see. So I'm just going to accept that, and there's that slit. Okay, one thing I forgot to do, I actually wanted another wall here, like so, and that's going to be here. That's perfect. And for that, simply put, let's actually do another T connection here very quickly. Just press space to do that, to accept that, and another one here that will allow me to get this connection going. Yep, that's done. So as you can see, that's very fast, very quick, and with that quickness, I'd like to also follow that up with just being able to mirror some walls. So I'm going to do that. Click, click, like that. My walls are now marked for mirroring. I'll just need to find the actually the midpoint of my line here. Select that, and walls are done. Basically, my double walls are now done. My stairs are nicely aligned, and that's all good. With that, once I'm done with this, basically, I can also go ahead and, for example, generate braces. So I'll just do that on, for example, this wall, and I'll get an information about the braces, bracing anchors if there are clashing braces between elements, base elevation and whatnot, as well as the diameter of the brace, as well as the angle. I'll just accept that, and immediately I can see that there has been a brace created. So let me go to the 3D view, and there's a brace attached to a brace point in that. There's also multiple girders in the visible in 3D view. Before we move further, how to actually move the girders about. Okay, so in order to do that, I can click on this tool. I can select a wall. So for example, let me select this one, and I can move a girder space, and I can move that to a previous or next location. But you see, it gets marked red once I move it, because it has been placed in that nice sweet spot with between minimum and maximum distance from the edge of the level wall. And with this option, I'm moving it by 300 mil, which is the spacing of the girders that we have, and we're moving it basically too far, too close, and so we don't really need to change the position of that. But if need be, then of course you can add that. You can move that. If you need to delete a girder, that's how you do it, and you can create a new one, specify location, and basically it will place it at that nice little spacing that you have. And let's exit and exit, and that's it. That's how you do it. What I will do is I will also create openings, because that might be of interest to you. So let's actually create some openings. There's a couple of different ways to create openings. There's rectangular openings here, there's circular openings here, there's window holes and door holes. So what I'll do is I clicked on the door opening, I clicked on this wall, and I'll basically just start placing an opening of some dimension, because it doesn't really matter what the dimension is on screen, because you can still fix it here. For example, make it 2000, right? So that's good. And I can specify the spacing and then the exact placement of that. If I need to add reinforcement, if I need to cut meshes inside that, and whatnot. If I want to add an end stop, I can, for example, add an end stop, the small one, for example, and that's it. Or maybe 130 might be better, and let's accept that. And see, here we have an opening. If I rotate that, just be advised that that doesn't immediately update the refresh the element that the opening is in. So the girders have not been cut, but were not either. When we reopen the drawing, they will be automatically cut, or when we open the not the drawing but model, or when we actually create drawings. There you will have the girders cut. Same thing if we actually go for the window openings. Select this wall. Oops, I didn't select the wall. Okay, first corner here, like that. Let's go 150. Okay, distance from floor and 900, which will be perfect. And let's maybe add another end stop as well. Okay, and this is our opening. That should easily cut the meshes later when we do that. Okay, so how do you now actually get drawings out of it or save it? Because all the elements are unmarked. The process is a bit different than with other elements in Impact. We actually have to set the marks manually for our elements. So I'm going to select the walls. That works for double walls. And with that, the double walls will be saved with a prefix that we have set in the element settings. I start with element mark. It can be 1, draw order or selection order. That basically determines what numbering order is placed upon the elements. And as you can see, we have different wall types. Yeah, a bunch of those. I don't think we have 21. I mean, we might have actually 21 elements. Yeah, so that's it. Those are the walls for us. I didn't bother creating like openings between rooms and whatnot because this would take too much time in this presentation. There's really no need to do that. But yeah, it's done, it's saved. So now we can actually go ahead and create drawings for us in this instance. This will automatically also, while creating the drawings, those double walls will actually be saved to the database. That's when they are actually saved in the database, once we actually create drawings out of those. So there's 23 drawings. That should be fairly quick for us. Yeah, I'll just wait a bit until that's done. Those will be simple drawings with nice layouts, but very nice, very easy for you to get the drawings out, basically. So we already have some layout prepared, so you can get up and running with the drawings for double walls very fast. You'll get the views for the panel 1, panel 2. You might get a 3D view as well for the girders, if need be, like 3D views of the reinforcement as well. So yeah. So let's just wait a short while more. You basically see it live, how long it takes to create this many walls. That takes a bit. It's 23 drawings to get out of. That maybe was too much to demo at once, but still. With that said, once that's done, we will actually move to the form slabs. And for form slabs, basically the placement and whatnot. We'll play around with form slabs, moving the girders around slightly, maybe slightly editing the reinforcement, but not much. Yeah. Also, I'll show you how to set the elevation of the form slabs as well. Yeah. General stuff. Yeah, definitely I shouldn't have clicked on all 23 walls, but still. Some of the walls will probably be already saved to the database, so I'll just refresh the model for us. Yeah, well, since they're almost done, So let me go back to AutoCAD. Yeah, it's already done. So if I go back to that model we have, if I update that, refresh that again. Yeah, let's refresh that, and there's the final wall. Okay, so there's our double walls. Oh, I think yeah, I will probably have to fix that, but that's not a problem. We can just move over, change the elements later. Oh yes, I forgot. I was supposed to move this on the alignment of this wall. Yeah, that should have been inside this wall. I forgot to change the placement. That's fine. That's fine for the demonstration. Yeah, if I go properties, I don't think we can change that now. No, we don't. We don't. So that doesn't matter. That doesn't matter. It'll just look worse in the in the preview. That doesn't matter. I can move the whole building now to make it look nicer, but let's not waste time on that. Okay, so with that done, actually, let's move to the form slab. Oh, yeah, drawings. I've created drawings and I haven't shown them to you. Okay, so let's actually open up a drawing. So let's open up, for example, this wall, because it's a simple one. Basically, all the drawings for the walls are created as well. You see something loading on screen, and with that, I go to drawing, and I get a nice little view of the wall. I get the location of our girders, the exact positions of those as well, specified online every 300, like on a single line with continuous dimension, every 300 as set with our properties. We've got the size of the elements as well, the rebar for panel 1 that has been defined, so your horizontal and vertical rebar, and just the mesh for panel number 2. So it's here, it's visible. Yeah. Basically, you also get some mesh for reinforcement for the reinforcement in the first panel, and again a bunch of data about the wall itself. All right, and also 3D preview with the girders. You can of course refresh and regenerate like reinforcement in those panels. I won't do that for now because it took a bit longer than I wanted, so we still need to do the form slabs. Right, so form slabs. How do we do form slabs? Well, form slabs are pretty fast. Not pretty fast, very fast. Let's go to the form slab window. As was the case for the double walls, let's first start off with the definition. I have a bunch of form slabs defined, standard form slabs. You can also have pre-stressed form slabs. For those, I have no definitions right now in the project. And I have a couple of definitions of form slabs. So that's like a 550 mil concrete layer on the bottom with mesh and some fixed reinforcement as well. So in general, basically very similar to double wall, we have all our specifications available here. So our max width allowed for our form slabs, the thickness of the form slab itself, and the slab thickness overall. So basically how much concrete you not how much concrete you pour over the form slab, but rather how thick the form slab is with the concrete poured over it. Anyway, lifts basically automatically placed in those form slabs as well, depending of course on the mass of elements. The reinforcement specification, if we want the reinforcement just in one direction, or so basically longitudinally. I'm sorry. Getting colder in Poland, my throat is getting sore. So because it's getting all dry. Now, so reinforcement in the main direction of our slab, so basically longitudinally. The secondary direction, which is perpendicular to that, so basically your transverse reinforcement, you can specify if you want that, and your covers and where the reinforcement is, so which is on the bottom of the slab. Bend bars, if you include those, and how do you measure those, you can add those as well to the slab if something that needs to extend out of the slab. The mesh, so what type of mesh you use, basically the cover of that reinforcement, etc., and where is it placed. Lattice girders used for the form slabs. So as was the case for double walls, you have your lattice girders as well for your slabs. And the distribution, that's basic distribution, so basically the spacing of those girders and spacing that's allowed in bigger elements, tighter spacing. Of course, you can also specify a shape of an edge. Here you don't get a preview, but you can specify chamfers and where those chamfers are, on the bottom or top or wherever. And if you want, you can also attach insulation. I have none defined for this particular slab, so I can't add insulation, but you could if you were so inclined. And MISC settings, so various different settings on the slabs, as well as the prefixes as well for those. Let me accept that, and we will be using just this primary slab. Of course, this one, for example, is with insulation. It has some definition of that, polystyrene insulation, and the thickness of that, and how far off from the girders it is actually placed. So let me close that out, accept that. With that, let's go ahead and actually place the slabs. So let's drag the slab like so. Here we get the initial placement options for the slabs. So we can select the type of slab. So the first one that we used, as was just an error because some settings here by default placed by default, something changed basically. I had some different values set that are not compatible with this, but no, let's not worry about that. Let's go 3000 for the elevation of that, because I want to place my form slabs on top of my walls, and then we'll align the stairs along with that. Right, the mesh. So if you wanted to use a different mesh here, we could specify that. If you wanted to change the reinforcement to something else, we could specify that here. If we wanted a different lattice girder and spacing for those, again, that is where you set it. What you don't set is the secondary reinforcement. That needs to be set in the definition. Or rather, you could, yeah, you can't really do the definition in here. Let's not do bended bars, and I'm just going to accept that. What I'm going to do is I'm going to place the slabs by the window. I'm just going to select that and go ahead and do it this way. I'm going to do a support edge, not here, but on the other direction. So step to next. So this is going to be my support edge. This next one is going to be 0, and this one is going to be 80, like that. No slope, and let's actually rotate that by 90 degrees. Oops. Yep. And that's that. And let me choose the start point like that, and this slab will be the cut one. I'm going to apply this, and this is my placement. I can mirror that to the other side, which we'll be doing later. I can also copy those slabs as well with a Ctrl+C. Wrong, not here, bad copy. Actually, let's edit that, and let's maybe actually copy that on this point. Oh, wrong. All right, I should probably just mirror that then. Yeah, I can mirror that. That's going to be form slab. Let's mirror the form slab. Yep. I'll just move that to align everything correctly, because I see that it's not properly aligned. Yep. So that's pretty fast and easy. And of course, if we need, we can of course recreate those slabs here, or maybe we can change direction of those slabs. But yeah, let's try and do that. So if, for example, you need to change slab direction, you can of course do that. Yep, like that. Of course, you don't have to do it this way. You can just extend your slabs, for example, to the ends of panels, and then just have 0 on support edge. But what I'll do here, this is going to be 0. This is not. Step to next, 80. step to next, and 0. Yeah. Right, no slope, and for example, we can leave it as like this. And this actually makes it fit two slabs perfectly with no cuts in this direction. And with this done, let me go ahead and actually add the last set of slabs here, just so you can see how fast it is and how easy it is. Yeah, same type of slab, except what I'm going to do, I'm going to click through here. And change that to here. And I'm going to make that an 80. Skip to next. This one is going to be 0. Step to next. It's going to be an 80. And next and 0. So that's just basically the end cap as well. So that's the edges that you had defined here. They have no difference for me in this case, but just so you know, you can change that. And like that. Maybe let's change that to here. So 2 cut slabs, but previews. Yeah. And apply. Yep. So that's what I have now here. Those are my form slabs. If need be, if you need to create an opening of some sort, you can use this tool, draw a hole, right? And you can specify if that's a rectangular hole, polygonal, or circular. You could select an object. You can specify if you want to cut the mesh, or if you want to keep the mesh in your opening. If you want to do some filling and whatnot, how it's dimensioned, how it's annotated. If you want to add an end stop, for example, we can add an end stop, maybe this one, a bigger one. If you want to cut lattice girders or not. So all of those options available. So maybe let's go and add that in this slab, like that. And that's it. What I need to do now is I need to edit this slab, double click, select add here, and select all. Basically the software will find the find any openings that you've created within the outline of the element, and will add that automatically to the content of the element. So as you can see, the girders were cut, there's an opening and whatnot. In here we don't need an opening, we just need a solid floor, and that's it. That's basically how you play around with the form slabs and how to create openings. Of course, there's a bunch of different options: edit length, rotate slab, save it, trim and extend the slab, like to have it at an angle, or other options. So it's all there. What I'll do now is basically I'll mirror those slabs for us again. Select the slabs that I want mirrored, like that, and like that, and those are the only slabs that I want mirrored. Select the midpoint of here, should be good. Let's actually undo that because I didn't select the right angle. Yep. That's pretty fast. And midpoint. So if you make an error, it is very it's very easy to actually remedy the error, like so. And let's not delete the other elements, and that's fast. We already have multitude of form slabs available. With that, let me go ahead and actually in this instance actually let's set element marks as well, because you need to set those element marks for form slabs. So I'll just select that. It will find which form slabs are identical, which are not, and yeah, that's it for draw order. So those elements, those slabs are now done, and now I can save those slabs. The difference between form slabs and double walls is I don't have to actually create the drawings to save them to database. I can just save them, and once they're saved, they will be visible in the project manager. So we'll have a preview of that as well, and they're done. So if I go into the project manager and refresh that, and we have form slabs with openings. Those have an improper level. but easy to fix. Yep, definitely easier to fix. So we'll just move those by 200 up. So that's also very good to be able to check that. And with that, I'll just move to the front view and check the slabs that are too low. So those are the slabs that we want to move, and those as well. What I'll do is move them displacement. So we're going to use 0 displacement, 0 here, and 200 to the top, and that's perfect. So all our slabs are now at a proper level. Yep, they are good. Slabs are there. Oh, something happened improperly. As see, didn't move my slabs all where I wanted to. Yep, now it's good. Some error in inputs on my part, not an issue. Okay, so that's top view. That's those are our slabs. I can also make sure that they have proper elevations in there, so I can just save them to the database again, and that's it. Once they're done, let us create maybe 2 drawings, so it will be pretty fast, and instead of just going over and waiting quite a while for the drawings to get generated. So again, let's select maybe this one, the FS1, and let's select maybe one of the cut ones as well. So maybe this one, small slab, right? So just 2 drawings. Let's just accept that. It should be pretty fast. Just 2 drawings for us to have a look at. Yep, that's done. So as you see, I'm a bit faster. Let's open this one. Let's open this one. That's the first one, and that's the second one. That's already done. And that's perfect. Okay, so let's go to the drawing view. We have a 3D view. We have a reinforcement display. We have our basically our girders also set up, as well as a reinforcement view in this window. And for the other drawing, maybe I'll keep it in the model view just for it to be a bit clearer on the drawing without printing that. So darker background, more clarity. So you have the girders here, basically some additional reinforcement, red reinforcement, yellow girders. Girders are cut here, maybe warrants moving reinforcement a bit, and we have those girders as well. Now, if need be, of course, we can, for example, draw a lattice girder, and we can specify the type of lattice girder that is. Let's maybe do this one. And we can specify that from here to here and have that maybe not in the 3D view. Maybe let's not do that in 3D view, but let's do that in the 2D view. And we can add that girder here and maybe add the description of it here. And that's that. So we can of course add those girders, and that they will be added to the schedule as well. So you can add girders here as well, edit those, save them to material takeoffs. Of course, for both double walls and form slabs, you can export the data format to Unitechnic, so and other machine formats, so they can be, you know, input into machines, and your meshes can be welded and bent as they are required. So again, go back to the drawing, and we have our reinforcement. If I refresh that girder, it would be there, and that's that reinforcement as well. Now back to form plan or floor plan. We do have stairs here. How to do stairs? Those we do from the plan tab, and we use linked elements. What I will do is I will use the draw stair command, which will allow the software to take the geometry from the model, which I want to be total height 3200, thickness maybe 1500. I will need to take this geometry in. So the whole outline like that, and select that, get the insertion point, specify rotation, and whoop, that's too big, 150. Yep. And that's how the stairs can be automatically generated from the 2D view. What I want to do is I want to make sure about the geometry that it's set. So I want to also create a bar mark for my geometry. Let's call it ST1. That's going to be my element mark. I'm going to accept that. Right, that's going to be ST1, and those are the properties of that. Height of steps 24. They might be too, yeah, they're probably too tall, but for the sake of demonstration, no, they're definitely too tall, but for the sake of demonstration they should be fine. So with that, let's accept that and specify the placement of the element mark. And if I want to, I can actually insert more stairs like this in the model. I can rotate those as well, so maybe different placement of that space. Accept that and accept the placement. Oops, I don't need any more of that. So those are my linked elements. Now I can save them, all the linked elements, to the database. Now if I go to the model, let's refresh that. That should actually raise all my, yep, my slabs have been raised, and my stairs have been as well. That's an error. I probably should have made that 3000 for the top, because the last step was raised. So just a matter of actually that's good, because we still have concrete pour over on that, so my levels are actually good. Okay, so that's good. Here, of course, this is a stairway to nowhere really, so let's not worry too much about that. But yeah, so that's how you create linked elements in terms of stairs. In terms of other linked elements, like for example here, that's a concrete footer for the column. I've created that previously. The way I created that basically is I've created a geometry in AutoCAD. Let me just show you. With end object isolation. And that's the F1 footer. Name is overlapping with the column here, but that's a footer. Basically, that's just the box geometry for the for that footer, and you can, using this option, create link, you can actually specify a mark for this particular element in the model. And once you have it, once the element is saved actually as F1, you can reuse that element in your model. So yeah, you can use that linked element as a column base for the elements here. So just this one, you can copy that over, and software also know the properties of that, like the volume and mass and area, and you can create drawings out of it as well. And with the let's go back to the DFS1. Basically, You have a bunch of tools in the element tab that allow you to add reinforcement to your drawings. So you can so since, for example, if you have like one pad footing as a linked element, then you can just create one drawing, add reinforcement to that, and you will be able to reuse that throughout the project all over. And yeah, that's it. That's how you can do that. So you can draw in bars, you can draw in meshes, you can draw bent bars and whatnot. So a multitude of options for you to choose from in terms of how to create and edit linked elements as well. Okay, so I think that would be a wrap. So basically, yeah, let me go ahead back to the model. Let's draw solid, include reinforcement, include casting material. That should actually include that. Didn't. Yeah. Let's regenerate that. Let's actually regenerate the drawing. It should actually add that 16 rebar found. That's good. Okay. Yeah. So basically, this is the type of drawings that you get. So what we've done today. Again, let's go back to that presentation of ours. So we did modeling, double walls, form slabs, how to edit elements, how to add connections between, how to create joints between walls. We did edit the girders in a wall. We did edit girders in the form slabs as well. We saved all the elements to the impact database. We did linked elements as well, stairs, and we've discussed other linked elements as well. And we've of course generated shop drawings of various elements. And those the model that we've created is visible here. So we've added a bunch of double walls, form slabs. We've added, as well as mentioned, linked elements. We've created those drawings. So for our double walls, again, we get a bunch of details automatically scaled to the drawing size, so it fits nicely and looks nicely. There's the form slab drawings as well, which look very similar to the double walls, really. Which are automatically again scaled for you with a lot of descriptions, a lot of labeling and dimensioning as well. So all fits and all good and all nice. With that, that would be a wrap. That's all the general workflow features in Precast Detailing in AutoCAD for Impact 17. And that would be it from me. I would like to thank you for your attention. With that, I would also like to invite you all to our Strusoft LinkedIn page, our Strusoft YouTube channel, where we have a bunch more info available, more webinars on different topics, on the Revit version of AutoCAD, on the production suite of the Impact, and other software from our company. And we would also like to invite you to strusoft.com and our wiki for Impact, so you can learn more about Impact in general. Okay, and again, thank you for your attention, and hopefully see you in the next webinar.